Dear student, after having conceptually important understanding about the FIR filter designing from the last lecture, now this lecture is being focused towards the designing of FIR filter using windowing method. So, if we want to design a low pass filter with the desired frequency response, and this is a desired response, means the ideal response of the low pass filter with the cutoff frequency omega c, and have clear demarcation between the pass band and stop band. In order to complete the mathematical representation of this desired frequency response, there will be the negative frequencies into the response as well. So the overall shape of the desired frequency response will be of rectangular shape, and we are very much familiar that if we take the inverse Fourier transform of this rectangular shape function, we will have a sinc function. So this is a sinc function that is the desired impulse response for this ideal response. And in the case of FIR filter, because the impulse response should be of finite length, so we have to multiply this desired impulse response to a window, okay, to make the length of response up to a finite length. Window as a distal sequence is a sequence of samples, unity sequence of unity samples in the desired length, and after that it will be 0. So mathematically the expression will be like that, means in the range that lies from minus n minus 1 by 2 to plus n minus 1 by 2, the sample signal is a unity and otherwise it is 0. So this is basically a rectangular shape, and this rectangular shape will have a Fourier transform, a sinc function, because rectangular shape has a Fourier transform, sinc function, or vice versa. Means if we take a sinc function and take its Fourier transform, it will be a rectangular function, or if we take a rectangular function and then take its Fourier transform, it will be a sinc function. So this is because this is window is of rectangular shape, so is corresponding Fourier transform will be a sinc function. So this is a response of the window, and in this case we can see there is a main lobe around 0 frequency. So this main lobe contains most of the energy of the signal, because here the amplitudes are high and energies are the amplitude square and some of the amplitude square in that region. So most of the energy are confined in the center lobe, whereas in the side lobe the energy is much smaller than the center lobe and decaying towards infinity. So if you want to design a finite length filter, means you have a finite number of terms. Suppose if you want to design nth order of filter, nth order of FIR filter meaning is that you have n number of terms. So means the window should be of the length of n, and this n length will be equally distributed on both the sides, means minus n minus 1 by 2 to n minus 1 by 2. So when you multiply Wn to Hdn, you obtain Hn, which is the actual impulse response, like this. Time domain multiplication will lead to the frequency domain convolution, because the Fourier transform is always a periodic function. So both the desired frequency response and desired or the response of the window, frequency response of the window, both are the periodic signals. So the convolution of these two signals will be periodic in nature mathematically, and it is expressed here in mathematical terms. So when you convolve the frequency response of window with the response that required ideally. So you have the convolution of these two in this form, means here the ripples are superimposed in and appear in both pass band and stop band. Now, any realizable filter should start from n equal to 0 up to some positive value of n, because realizable filter is a causal filter. But in this case, what we are seeing, the filter that is actually we are getting have the coefficient from minus n minus 1 by 2 to n minus 1 by 2. So, in order to get a realizable filter, we make a delay of that number of sample so that the overall signal will be shifted from this part to this part, means the last sample that is at n minus 1 by 2 should be at n equal to 0. So means we have to make a shifting of overall response, and the first sample now should start from n equal to 0, and this is now look like in this form after shifting. So means you have to shift Hn by alpha number of samples, where alpha is n minus 1 by 2. So now important characteristic of the window, because we know that whatever the shape of the window, that will affect the actual response. So the desirable characteristic of the window is that the most of the energy should be in its main lobe, and the first side lobe should have as minimum possible energy, and this energy must decay rapidly when goes from 0 to pi. So center lobe of the frequency response of the window should contain most of the energy and should be narrow. The next thing, the highest side lobe level of the frequency response should be small. The side lobe of the frequency response should decrease in energy rapidly as we tends towards pi. So this side lobe must contain as minimum as energy as possible, but after this side lobe there must be a fast decay towards pi, and this main lobe should be as narrow as possible by containing most of the energy in it. So this is a windowing method, and now in the next lecture we will discuss the different shape of window and how the shape of the window affects to the final designing of the actual response. Thank you.